First, I want to thank Morgan for submitting this copy so that we can go over these answers. Appreciate you sending me the copy of the actual test. So let's start with problem number 1. Find the domain. So anything that is underneath the square root has to be greater than or equal to 0 for a domain. Greater than or equal to 0. So all I'm going to do is solve this. Move that over there, divide by -4, flip the sign because I divide by a negative. So x is less than 7/4. So in numeral notation, it would look like this. Don't forget to put that bracket there. You are including the 7/4. Okay. It's 0.00 on the graph of r of x. Well, let's find out. If I put 0 on here, I get -4 times 0 plus 12 over 0 plus 0 minus 3, which is -4. So the point 0, -4 is on the graph, but no, 0, 0 is not. What is this domain? So this is going to have problems when the denominator is 0. And that's going to happen at (1) and -3. So our domain is going to be from -infinity up to -3, not including -3, -3 up to 1, not including 1, and 1 to infinity. All right, so what's R5? Well, let's plug in 5 and find out. -4 times 5 plus 20 over 25, which is 5 squared, plus 10, which is 2 plus 5 minus 3. -20 plus 12 is -8. 35 minus 2 is 32. Negative, make a positive. 8 goes in. I'm sorry, that's a positive. It goes in exactly 4 times. So this is indeed -1/4. What are the values when this equals 0? So this is going to equal 0 only when the numerator equals 0. So let's find out. When does this numerator equal 0? Well, it would be -12, so -x equals -12, and x equals 3. Now, as long as 3 is in the domain, we're good to go. But if this was a 3 that was not in the domain, if we would have a 0 over 0, then we'd not be good to go. But this is not, so x equals 3 is the correct answer. So what is r of x if x is 20? So let's do that real quick. So I have -4x plus 12 over x squared plus 2x minus 3 equals -20/3. So let's cross multiply. I got -12x plus 36 equals -20 times x squared plus 2x minus 3. All right, I'm going to take a 2 out first. So that's -6x plus 18 equals -10 x squared minus 40, that should be now 10, right? Minus 20x plus 30. I just took a 2 out of everything. I could take another 2. I could have taken 4 out, but we'll get there. All right, so let's add the 6x to both sides. Subtract the 18 from both sides. We get 0 equals negative 10x squared. Minus 14x plus 12. Let's take a 2 out. And let's take a negative out. I'm just doing this so it will be a little easier for me to factor. All right, things that multiply. So I have 5x and x here. 6 and 1. No, 2 and 3. 2 and 3 is 10. So yep, 2, 3. That's 10 minus 3 gives me 7 in the middle. I need one of these to be negative. Minus the 3 to the positive is 10. And so it equals 0. And now I'm going to say x equals negative 2 or x equals, add the 3/5. Let's find out which one works. So make sure there's not any extraneous solutions. So I had negative 4x plus 12 over x squared plus 2x minus 3. Plug in a negative 2 and I get 8 plus 12 over 4 minus 3, which is 20 over negative 3, which is negative 20/3. So this one works. Let's try the 3/5. I get 4 times 3/5 plus 12 over 9 25ths plus 6/5 minus 3. Okay, let's multiply a couple things out. So this is negative 12 over 5 plus 12 over 9 25ths plus 6 25ths minus 3. Let's multiply top and bottom by 25. Should simplify this way. All right, so 25 into there gives me a negative 60. Right? Because this 5 cancels with that, and then 5 times 12 is 60. And 25 times 12, hang on a minute, let me tell you what that is. $300. On the bottom I have 9, cancel, plus 30, and minus 75. So top I've got 240, and the bottom I have 39 minus 75, just negative 36. 240 divided by 3 is 80 over negative 12. 80 divided by 4 is 20 over negative 3. They both work. So my answers are going to be x equals negative 2 or 3/5. Okay, that's page 1. And so here's page 2. Consider the function of the graph at the right. A function has a minimum. This minimum, it doesn't have a minimum. It goes on forever down, so no minimum. But it has a maximum, circle that, of, maximum is at 6, at 2. The function is increasing, going up from negative infinity. Remember that these always stop at the x-axis. We're always talking about the independent variable up to 2. Function then is decreasing from 2 to infinity. The domain of this function is all real numbers, and the range of this function is from negative infinity up to 6. Now it says consider this function. This function has a relative maximum right here at 3, -1, and our maximum is -1 at 3. Has a relative minimum down here. I can't see this in the picture I got. So whatever this point is on the x, I can't see. Let me see if I got a better picture coming in. Just one moment, please. So we did have a better picture coming in. That came in. So thanks again, Morgan. So this was a relative minimum at -1. And at x equals 3, and then it has a relative, maximum, that's max, minimum right here of -4 at 0. This function is increasing on the intervals just from 0 to 3, and decreasing from -infinity to 0 and 3 to infinity. The mean of this function is all real numbers, and the range of this function is all real numbers. So that's number 4. I'm sorry, I did all that work and didn't record, so I'll do it real quick again. First you go up 3, 1, 2, 3. Okay. So you go up 3, 1, 2, 3, and then it's an x squared, so you go over 1, up 1, over 2, up 4, because it's squared, over 1, up 1, over 2, up 4. Squared, draw it in. That's what it looks like. It's increasing on the intervals from 0 to infinity. It's decreasing here, going downhill, and then it goes uphill from -infinity to 0. Has no maximum. It goes on and on forever uphill. It does have a minimum right here at 3 at x equals 0. The domain is all real numbers, and I would take this for full credit, and the range is from 3 to infinity. It asks you to graph the inverse on the same grid. I was just saying before I realized I didn't have to record on that the inverse is the reciprocal, or is the flip of this over the y equals x line. So if you reflect this over this line, that's what gives you the inverse. So where y is 3, then x is 3. Where y is 4, then x is 4. So I go over 1, up 1, over 1, up 1 this way. Okay. Over 2, up 4, over 2, up 4 this way. That's one too many. And it looks like that. If you were to draw a perpendicular line across that, these would connect. Perpendicular line would be exactly perpendicular to that y equals line. Across that way. Same distance on both sides. You just switch the x and y's. So if you had trouble doing this, you could, inverses are just switching the x and y's. You could just make yourself a little graph. Oh, I have 0, 3. Therefore, my inverse, I'm going to have 3, 0. Oh, I have 1, 4. Therefore, my inverse, I'm going to have 4, 1. It's that easy. Don't make it harder than it is. It's hard enough. Okay, name the function of the graph on the right. All right, so name the function in the graph. Select the equation of the function of the graph. Okay. So this is a rational function. Yep, because it's, going to be that. And so it has to look something like one of these. That's our only rational function. Give the function, the domain of the function, Well, it blows up at 0, so this is correct. The range of the function is not defined at 0, so yeah, this is also correct, right? So great, good job. And let's take a look at our next page. All right. So we have, select the name of the function. Look at this. This is a cubic. So that is correct. And a cubic looks like this. Excellent. Domain is all real numbers. You could also write this, but I would take what's there. The range is all real numbers, right? So let's find the absolute maximum and minimum for the given graph. List the x-coordinate only. Well, the absolute maximum right here is -3. Right? It says, hint, list the x-coordinate only. So this one right here, point right here, is -2, 0. So your maximum is 0 at x equals -2, and it only wanted the x-coordinate. Right? List the absolute minimum. That's at the point 1, -3, and they only wanted the x-coordinate. Okay. Skipping that next one, so don't worry about number 9. And let's go on. So 10, we want to find the composition of f given g and g given f. So f of g of x. So wherever I see, so this is going to be f of 3x plus 7. Put g into f. So 1 over, now wherever I see an x, I'm going to put 3x plus 7 minus 7. That's convenient. Look at that. 1 over 3 over x, which equals x over 3. Right? Now I want to find g of f of x. I could have saved myself a little more room for this. I'll put it over here. G of f of x. So wherever I see g of f of x, g of 1 over x minus 7, which is 3 over 1 over x minus 7, plus 7. Less convenient, which is equal to, I'm going to invert and multiply. So this is going to be 3 times x minus 7, because 3 over 1 divided by that, you just flip it up, right? Multiply. So this would be plus 7. So this is 3x minus 21 plus 7. So this is 3x minus 14. Okay. If f of x equals this, and this, then it wants us to, again, find our composition functions. So, all right, f of g of x. F of x squared minus 7x plus 6, which is equal to 2 of x squared minus 7x plus 6 minus 3, 2x squared minus 14x plus 12 minus 3, 2x squared minus 14x plus 9. Right, next one. All right, g of f of x. G of f of x. Put f into g. So 2x minus 3 squared minus 7 times 2x minus 3 plus 6. I got to FOIL this out. 4x squared 2 times -3 is -6 times 2 is -12x plus 9. First thing, pull it out. Minus 14x plus 21 plus 6. So 4x squared minus 26x plus 36. Right. Okay. And find the inverse. That's our next one. So y equals 1 over x plus 10. That's f. Switch the x and y's. X equals 1 over y plus 10. Solve for y. Multiply x, y plus 10 equals 1. Divide by x. Y plus 10 equals 1 over x. Subtract the 10 from both sides. Y equals 1 over x minus 10. Right? All right, and same thing. Y equals this. Switch the x and y's. And so I get x equals 4 minus x squared, or y squared, sorry. Switching the x and y's. X minus 4 equals negative y squared. So now I'm going to multiply everything by negative. Now I'm going to get 4 minus x, because I have a negative, equals y squared, square root. Y equals plus or minus the square root of 4 minus x. But when we did this, we only had the positive ones. That's so that we could actually make this. So this was like, this looked like 4 and going down like this. You only took the positive ones here. So when we flip this, instead of it being 0, 4, it's now 4, 0. Going like this, right? Oh, going like this. So our positive numbers here correspond with these positive ones up here. That's only the pluses. So 4 minus x, only the pluses, because this is positive. All right. All right, so we want to do the inverse one more time. All right, so we let y equals that. Then we switch the x and y's. Then we solve for y. So x minus 2, divided by 3, and x minus 2 divided by 3 is correct. Verify these are inverses by showing their work, and that's the one for number 14. Verify these are inverses. So let's show it. If I take 3 of x minus 2 over 3 plus 2, then these cancel, and I'm left with x minus 2 plus 2, which is equal to x. So that works. Now if I plug f of x into my inverse, I end up with 3x plus 2 minus 2 all over 3. These cancel, and I get 3x over 3, which is just equal to x. And that works. So good job verifying. All right, next page. This one, I believe. All right. So these are the ones that we just got done with, homework 8s, and these will be homework 9s. which we'll do more practice on, but they're nothing too extravagant. So first you want to solve for this thing by itself. Let's get that thing all by itself. So I'm going to subtract 136 from 109. So I'm going to have 3 times that thing equals 904 minus 136, 768. Divide that by 3. I get 256. So I get 4 to the 2x minus 1 equals 256, which is a power of 4. 4 times 4 is 16. Times 4 is 64. That's 3. Times 4 is 256. Right? So 2x minus 1 equals 4. Those cancel. 2x equals 5, x equals 2.5, right? On this one, in order to solve these problems, you have to get the equations, all the logs gathered together to one log, right? So remember, if something's in front, it can go up there. So this is the log of x squared minus the log of 8. Or also, the log of 8 is just a number. We'll take care of that in a minute. When this is the log of 64 times 2, which is 128, because when you add, you're multiplying with logs. And when you're subtracting, you're dividing. So this is the log of x squared over 8 equals the log of 128. And if you have a log equal to log and they have the same base, this is the common log, both base 10, they can be canceled out on each side. Just have x squared minus 8 equals 128. We'll multiply 128 times 8, 2024. And we'll take the square root of that. $32. X equals 32. All right. Now on this one, we only have one log here. So what we're going to do is, just like up here, we're going to solve for the thing with the log and get it all by itself. So we have the log of 5 of x squared minus 6. Take the 8 away from both sides equals 1. Now we're going to use, what is the definition of a log? Log says this base raised to this power equals whatever over here. That means that add 6 to both sides. X squared equals 11. And therefore x is equal to plus or minus the square root of 11. But logs can't have negative things inside. So does negative square root of 11 equal work out okay? Let's find out. If I put a negative and I square it here, then I still have 11. Yeah, they both work. They should both work. Negative squared minus 6, they both give you 11. Yeah, they should both work. So x equals plus or minus the square root of 11. All right. And this guy is a quadratic type. So take a look at this funny little guy. Let u equal e to the x. Then u squared equals e to the x squared, which is e to the 2x. So this becomes u squared minus u minus 6, which we know how to solve. This is u minus 3 and u plus 2. So u equals 3 or u equals negative 2. But u is e to the x, so e to the x equals 3. Or e to the x equals negative 2. E to the x is never negative 2, so that's extraneous. And so e to the x will equal 3 when x equals, take the natural log of both sides. Those cancel when x equals the natural log of 3. Notice that negative 2 doesn't work because e to the x looks like this. And it never crosses over to get to be negative 2. All right, find the quotient and remainder using long division. All right, so we're going to go set it up here nicely. X goes into x squared exactly x times. And take x squared plus 3x, multiplying it in. Change the signs and add. And that gives me 11. I'm sorry, change the signs. Gives me 5x plus 20. Goes in 5 times, so plus 5. That would be 5x plus 15. Change the signs and add. Goes to 0. That goes to 5. We have a remainder 5. So the quotient is x plus 5, and the remainder is 5. Synthetic division, so we have that, divided by that. Put 2 here. And we have 1, 9, 15, 7. Drop the 1, 2. I'm sorry. Should put a negative 2 here. So we have to change the signs and add. I forgot to change the signs. 2, 7, negative 14, 1, 2. Negative 2. 5. So our quotient is x squared plus 9x. What are you doing? X squared plus 7x from here plus 1. Remainder is 5. Let's just double check this just because I didn't put that negative at first. So let's just do it long division and check our work, shall we? All right, so x goes in x squared times. So far, so good. X times that is x squared. So plus 2x squared. Change the signs and add. That's why you have to put the negative there, because it's change the signs and then add. Otherwise, you're just adding. So 7x squared plus 15x plus 7. How many times does x go into 7x squared? It goes in 7x times. Looking good so far. 7x squared plus 14x. Change the signs and add. And this will go in 1x. And that's x plus 2. Change the signs and add. Remainder of 5. Good. So no reason you can't use the other methods to check both methods. So let's check this method. 1, 8, 20. Put a negative 3 here. 1, negative 3, 5, negative 15, 5. So this is 1x plus 5, remainder 5. Love it. Looking good. Okay, next one. And should be, here we go. Okay, and we're going to condense. So a single logarithm. So remember, this guy is going to go up here. So we're going to have log base 4 of x plus 3 squared. We can plus log base 4 of 5 minus log base 4 of 10. Good. Adding, so we multiply, so this is log base 4 of 5, x plus 3 squared, minus log base 4 of 10, and 10 you're dividing, so that becomes here, and you can simplify that and take a 2 out, and this is a correct answer. Factor the following given that one root is -2. Well, if one root's -2, let's throw a -2 up there. So we have 1, 4, 1, -6. Don't need any placeholders. I've got 3, 2, 1, 0, so we're good. Drop the 1, -2, 2, -4, -3, +6, 0. If this wasn't 0, I would know I did something wrong. So now I have my factors so far are z, because we're using z's, z plus 2, because you changed the sign, right, times z squared plus 2x, 2z minus 3, right? So now I can see if this last guy factors. Let's see, z plus 3 and z minus 1. And there you go. All right. The polynomial has degree 5. The leading coefficients 1. The roots have multiplicity of 2 at x equals 4 and 0. And a root of multiplicity of 1 at x equals 3. Find a possible formula for g of x. So leading coefficient is 1. So g of x is equal to multiplicity of x equals 4 that's a root. So I'm going to have x minus 4 squared. X equals 0, so that'll just be an x out here. And multiplicity of 1 at x plus 3. Has polynomial degree 5. It's leading coefficient of 1. Check. Has the roots of multiplicity to x equal 4 and 0. Oh, these both have multiplicity of 2, so that should be x squared. And notice we have 1, 2, 3, 4, 5 roots. And so there's our formula. All right. Back to the following completely given that one of the roots is 2. 2. 4, 2, there's a 1 and a 0. 4, 8, 10, 20, -50, -100, 0. So now we have x minus w minus 2, 4w squared plus 10w minus 50. So w minus 2, 2w, and how is this going to factor? Is it going to be 4 and 1, or 2 and, so, or 4 and 1, I need to get 10, or 2 and 2, 2 and 2, and this could be 50 and 1, 2 and 25, 5 and 10. This one seems most likely, huh? What do we got there? We got 10 and 20. That will give me 10, yeah. So 2 and 2. And then one has to be negative, one has to be positive. All right, and we want the bigger number to be positive, so the middle is positive, and the smaller number to be negative. There we go. So P of W equals W minus 2, 2W minus 5, and 2W plus 10. All right, that's that page. And we just did this page, so this must have been the last page. And if I missed anything, let me know. But hopefully this will help you out. Thanks so much.